Alright students, I'm going to show you how to collect and analyze the data for round 2 so that we can see how this is done, hopefully without any issues. The first thing we need to do is open up the graphical analysis program, and we're going to open sensor data collection. Now if you're using the Bluetooth, you can connect your device via the Bluetooth. I'm going to go ahead and click done and just plug it in manually. Once it's connected, you should have an absorbance reading down here. And that absorbance reading should move if you put distilled water in it, or if you put some of the solution in it or anything else. Right now it's just going to stay at that 0.15 because it's empty. We're going to collect the data before we put in the calculated columns. So I want to see the table here though, so change this to graph and table here, and then I have the only thing I need to change before doing this lab is going to be the time. We're going to record this reaction for 180 seconds. Once we're there, you're going to go ahead and do the reaction as it outlines on the back of the handout, procedure step number 2 for collecting the data, and then you'll do that process. Once you have that done, so I'm going to collect data for just a short little bit of time. This data isn't going to make any sense because the colorimeter is empty, but we'll at least have a couple data points in the data set that we'll be able to use as we analyze this thing. Alright, that's about 10 seconds. That's enough. So we have 3 different columns here. After you collect the data, that's when we're going to start messing with these columns. First of all and foremost, you will not change anything for the transmittance or absorbance. Don't change those columns at all. We need to add a new calculated column. This calculated column is going to be the natural log of the absorbance instead of crystal violet. Since we're not doing concentration, we're actually just doing the absorbance. As it changes over time, we're just going to call it absorbance because that's also what it's called here in the data table. That way when we do our insert expression and we do the natural log of it, we're going to make sure that it says natural log of absorbance. Apply fit. Now we have that graph on our data table as well. Now we can add the inverse, add calculated column. 1 divided by the absorbance. And this time the expression is going to be A over X. Oh, and this says this is wrong now. We want to make sure that if this doesn't say 1 over absorbance, it says 1 over a natural log of absorbance. We're going to change that so it says 1 over absorbance and apply. Once we have our 3 graphs, we'll have several different options here to analyze. First, we want to make sure that we look at one graph at a time. So we can toggle graphs by clicking on the check marks for each of them. And we're going to start with the absorbance graph. So this is going to be time versus the absorbance. This would be our 0 order graph. When we have that graph up, we can then apply a curve fit. This curve fit is going to be the linear, and that's what it will default. And if this is the most linear curve that we have, we will use the slope from this as our constant. We have our y equals mx plus b, and so on. That will be it. Now we're also going to go through and look at the natural log of the absorbance and do the same thing. Apply curve fit. Then we have our slope there, and we would do the exact same thing for the inverse. And then whichever one of those is the straightest of the 3, that is your order, as well as how you get your constant.